Hello, I think we'll get started now. Welcome to tutorial 3, which is entitled Build Your Own Social Virtual Reality with Ubiq. So we've got a 3-hour tutorial. It'll be quite hands-on in the second part, or at least there'll be quite a lot to follow, quite a lot of detail about how to get working with Ubiq. The key message is that it's completely open source, so under an Apache license, so you can develop your own systems and use them as you will. Okay, so just to introduce things, I'm Professor Anthony Steed. I'm head of the Virtual Environments and Computer Graphics Group at University College London. And I just celebrated 30 years working on virtual reality. Well, celebrated. I have been working on virtual reality now since starting a PhD in the topic in October 1992. The other two presenters today will be Dr. Sebastian Friston, who was the lead architect of Ubiq and still is involved in development, and the newly minted Dr. Ben Congdon, who is working on the main code full time. And I said newly minted because he passed his PhD a couple of weeks ago, which was great for the lab. So what we'll do today is, I've given the introduction essentially. This is the timetable. So we've got me talking for about 15 minutes, giving just a general information about social VR platforms, a little bit of insight into what you can and can't do in commercial platforms, and then leading up to a sort of motivation for why we developed Ubiq. And after that, Sebastian will talk a bit about Ubiq's structure, how it works, and some of the decisions we made to make it quite reusable. As I'll explain, we don't see this necessarily as for developing commercial applications, more for research and teaching. So for some of the features in the toolkit are targeted at doing exploring and experimenting with how the actual software works. Then we'll have a quick break, depending on how many people are on board. We can try some Ubiq. We'll point you at a demo online where you can just try it in a web browser, and then Ben will lead us through a really interesting tutorial on how to build a pen, I think, in 3D. So not your Ubiq comes with avatars built in, things like picking and sharing, moving objects around, and a few other things. So Ben will do something a bit more sophisticated and show you how easy that is in the software. Okay, so anything you need to know about Ubiq will be provided through ubiq.online, including eventually a version of this tutorial edited to make it flow slightly better. All the code, of course, is on GitHub, and including the code for the tutorial. And you can email all of us at ubiq@cs.ucl.ac.uk. But the website and the first one lists everything you need to know. Okay, so I'll start off with possibly my favorite topic, which is just covering in brief what social VR platforms are, what they do, and some of the questions you might want to ask, and therefore some of the reasons you might pick up Ubiq as the tool of choice. So many of us in the field are motivated by this vision of from Neil Stephenson's Snow Crash about the metaverse. There's some notion that people will get together in social virtual reality and have experiences that range from going out on dates, through seeing lots of other people, going to destinations to share these with other friends. these days, this is coming to pass, right? There are lots of platforms out there that achieve at least some parts of this vision, and there are other books, other movies that sort of give this a bit more wow factor to it. I enjoy Snow Crash because it's, you know, it's got the mundane details of how life in this might work. And of course, these systems have existed, like certain parts of this sort of vision were visible out in the world before that. VPL's Reality Built for Two predates Snow Crash. And so before Snow Crash came out, there were virtual reality systems that had two or more people in them. And of course, military simulators like SimNet had been in existence since the 80s. Yeah, so these are all, you know, these systems are very customized, right? They're the internet at the time is a bit of a research curiosity. The web hasn't happened yet, so they're often built on their own networks with custom hardware and so on. But where I got started, I didn't work on social VR for my PhD, but my first postdoctoral job was in social virtual reality. And so by the late 1990s, there were a number of platforms. Don't have time to recount some of the platforms there, but here's the one I was working with from the Swedish Institute of Computer Science called Dive. And Dive was pretty sophisticated, and I would have said that until about a couple of years ago, I hadn't seen anything with all the features of Dive had. But it's built on SGI workstations, so you know it's pretty high. Price of entry is pretty high. You need to be on an academic network because it used a specific feature of the academic internet called multicast. But it did support 20 people all talking to each other with spatialized audio. And that number 20 is surprising. It'll come up in other contexts that even today, platforms don't tend to support very large numbers of people talking to each other. And it is a bit of a limit for the audio in Ubiq as well. And that's because of the underlying network technology. It's nothing to do with Ubiq specifically. But if you're going to use web audio, even today, you have to go to a specialist company to get lots of users. So, so all of these things are present. There is lots of precedents in social virtual reality. If you get into the history, it's really fascinating to look at some of these systems. I'm still fascinated by the languages, the software languages that some of these were written in, like MUDs and MOOs. There's a lot of experimental programming language work in these systems. Like how do you represent something like a multi-user to dungeon or dimension in code and text? It's really interesting, and that you can see here some of the famous systems that people built, like Habitat, Alpha Worlds, Active Worlds is probably the oldest still running 3D. If you've never seen there, you can still visit it online. And then obviously certain games like Doom and Quake are not only notable because of their influence on the gaming community, but they had quite an influence on the networking community around these software as well. And people will still refer back to some of the things that they did in the Doom and Quake games as being, you know, showing you how to actually implement basic games from scratch in networking terms. Of course, we've had today. I don't know if we'll have time to talk about WebXR. Maybe we'll just mention it very briefly that we can deploy Ubiq to web browsers and run it inside there. But of course, there have been VRML in the past, and there have been multi-user extensions to that. And of course, there's Second Life is still with us and still one of the largest online social spaces. Okay, so there's a quick plug here for the book. I wrote with one of my former PhD students, Manuel Fravino Oliveira. This book is now a little bit out of date. It predates, it's from about 2009, 2010. It predates the sort of explosion of VR, consumer VR systems. It's written in with mostly games and network, sort of high-end virtual reality systems in mind. Who knows, there might be a second edition at some point that brings it on board all the recent developments in the sort of consumer client interfaces. But the underlying networking, not much has changed since then. Okay, so what do we want from your social VR platform? So when you different platforms have just very different rules here. So the key thing is, as researchers, and if you're thinking about implementing features, you've looked at the online systems and you're thinking about the features, then they've got very different capabilities. And even at the sort of very basic level, that you've got a primary awareness system, which we call the social VR system, right? So you go on site, you see avatars, you see people walking around, but actually, as soon as you get into it, some of the most interesting things is how you get people on board, right? So how do you find each other? So a space like Rec Room has friends list, it has lists of worlds, and you can sort of consider these to be sort of secondary, well, no, that would be tertiary awareness, that there is a universe there for you to transport yourself around. And in the middle, there's a sort of space where you know that there are people nearby and you can walk to them. And I would consider something like Verbella to sort of provide a sort of a primary awareness of a few people near to you, but you have a sense that you're in a large space with more people. And by walking around, you could encounter more people. So even here, there's lots of interesting things to think about. Your world, at a very high level, might have editing. Right? Is it somewhere people go, or is it something they build? As soon as you've thought about editing, you've got publishing and governance rules. And here you've got, at the moment, we've got platform providers that do everything for you. So, you can build, you can publish, but, the software provider like Rec Room is hosting your content and sharing it back to you. And then, of course, it's ownership rules. And if you've played online games or massively multiplayer online games, you'll know that these are sort of the stuff of governments, effectively. There are rules, laws, there are effectively people to police some of these rules and laws. Okay, so all sorts of questions you could ask, like what should users look like? How should we build the software? We quite looking at latency and its impact. What controls do users want? How will users move between the software? How do we control access and rights? And all of these are amenable to doing experimental work. Unfortunately, it's quite hard to do this type of experimental work in commercial platforms, as I'll explain. Okay, so so for the academic work, I mean, there's a few papers I'll just list here. This is a journal paper we wrote before the book that's sort of analysing what a social VR platform contains from a software point of view. What are all the roles that it does? What are all the components that it might have? And it's a very high level, quite an extensive survey of different strategies. Very recently, one of my master's students wrote this interesting comparison of 6 of the big social VR platforms and how groups do specific tasks. If you want to meet a group of people and do a particular thing, what are all the steps involved in these 6 platforms? They're very different. And in some platforms, it's quite hard to understand how to do certain things. And of course, if you've been on these platforms, there's a lot of switching between interacting with the world in a sort of didactic manner where you're interacting with objects moving around, and then a lot of fiddling around with menus in 2D. So eventually you pop up a menu and you click on buttons and go to place to move around or change settings and so on. So all of this is a little confusing for users, and all the platforms have different strategies. So I can recommend that. And not only just to look at those platforms, but as a way of reviewing other platforms as well. This is me in 3 of our favorite VR platforms, social VR platforms. We've sort of fallen out of doing it over the last few weeks because now we're back in the office over the last, but we used to spend some of Friday afternoons for about a year trying out all the platforms, and you can hope, bit of a quiz of which platforms those are. They're all famous platforms, nothing esoteric there. Notice I'm sort of dressed the same in each of them. I'll explain why some other time. Okay, so just a little bit of more motivation for why Ubiq. There's been some work in the, I would say in the ISMAR sort of IEEE VR communities, that people are more technically familiar with the tool, so more people building things, but more in the sort of sociology, sort of HCI areas, people have been trying to use the commercial platforms because they don't have access to the tools, and this is a little bit of the bridge that we're hoping to make. So we've seen a few papers written about using these commercial platforms, but it can just be quite hard to first make the scenario you want, because some of them don't allow you to edit very much. You're unfortunately at risk of them changing how things work, so your platform not working, your code not working for very long. There's a risk to services. It may go down, right? So if you find a particularly interesting commercial platform that isn't Rec Room or AltSpace, it may go away. A few of them have already closed over the last few years, or changed dramatically what they do. They've pivoted to do something else. There are some privacy concerns, especially there's a lot of these platforms that run off servers in the US. Unfortunately, if you're being very strict about data, that means that you can't use them in Europe, for example, under GDPR, because all your participant data is going to the US. We can have a discussion, probably a whole workshop, about how much of a concern that is. But as these platforms get more and more data about users, we have to be quite frank about that, that we shouldn't be sharing data all across the world. And of course, there are walled gardens. So there are certain things you can't do, like getting data back out again. Okay, so or comparing two systems, they're very different. So just to say that, and again, there's a longer discussion to be had about this. WebXR can provide some necessary features. Mozilla Hubs is a great platform. It's currently a little difficult to extend, and of course that binds you into the web model and the web security model, which is, of course, if you understand how all the software works underneath, is a bit of a constraint, and is one of, is a real debate to be had about the effectiveness of these platforms in the long term. Okay, so hence Ubiq. So we had a long history of working on social virtual entities, and we built several in the past, little toy demonstrators in a variety of different toolkits. We were using Photon in the past to do some of our work, but it wasn't what we needed for teaching. Certainly, we needed something that was simpler to explain, and we had some more control over, and also allowed us to run our own service and everything like that. So some of the things we've already done with it is looking at sort of issues of network. How do you network and manage networking between peers? It's a complete system. It's no other external services are necessary. If somebody else's server goes down, hopefully not a problem. Obviously, that makes you liable for your own service to go down, but at least might know where that is. It supports niche use cases, so it's a platform, so you can build stuff in Unity to add to it, do your own things. We use it for teaching. We've used it for teaching for 2 years. So during COVID, we had our master students build their own social VR demo, and Ubiq originated was timetables driven by the need to support that in January 2021. Yeah, where the students weren't coming to the lab. We've done lots of experimental work. In fact, there is a paper just come out this week. We haven't done any publicity about it because of other circumstances this week, where we've talked about how we run experiments online using Ubiq to do data logging or support multiple users. So that'll get more publicity soon. And again, as far as we can, we'll give away all the source code to those experiments, and it's open source. It's under an Apache license, which is effectively do as you please license, and obviously we just ask you cite the papers if you use it. So just a quick preview then of something we're doing in research. This is a paper that's coming out of VRST soon. This is Nels Newman's work on using Ubiq to do a collaboration with people in mixed reality. In particular, that's my office, in a scan of my office, and there's an augmented reality user and a virtual reality user, and they're collaborating, and Ubiq is the bridge, and there's the tools in there which Nels will eventually share to set all of that up. So the main problem being how to register the VR and the AR together. And we've also just done that outdoors as well. The next slide, I think Sebastian will show this as well. This is the output of one of the student groups coursework, which is amazing coursework. So it's called 2-Scale Maze. The students are listed at the bottom, and if you're a technical person, you can just see the complexity of this. You've got users at 2 scales. You've got miniature people running around a maze, and you've got giants. And I challenge you to find a sort of commercial software platform that's possible on. They've done some really interesting stuff in something we didn't think was possible, and we've actually scratched our heads about supporting such things natively, well, easily in the software. Okay, so that's me over. I'll hand over to Sebastian now. Here are the URLs again. I'm afraid I can't stay for the rest of the tutorial to answer questions. I have to give a presentation somewhere else, but I'll leave you in Sebastian and Ben's very capable hands. I'm the cheerleader, and I say things that I think you should do, and then it's Sebastian and Ben that implement them. So if you see a feature, you've got a hotline to the 2 people that you need to talk to. Okay, thanks very much. Enjoy the rest of the tutorial in ISMAR.
Okay, good afternoon, everyone. Thank you, Anthony, for the introduction. So for this next part of the tutorial, I'm going to introduce the Ubiq project, how it works and how it's put together. And I'll run through some of the design decisions at a high level before Ben gets everybody hands-on after the break. So some quick background. As Anthony says, Ubiq was created about 3 years ago out of necessity. It came out of a project called Chasms, whose goal was to explore the networking requirements for next generation, i.e. very high fidelity shared virtual worlds. So in 2020, we had to move our virtual environments course online with very short notice. And as we looked at what was available, we began to realize there were good reasons we were having trouble finding something suitable for research and teaching. This is the motivation that Anthony discussed, the need for a data protection compliant platform that is easy for students and non-networking experts to get started with, but that is also transparent enough that it can be used as teaching material. So we developed the first version of Ubiq in 2020 for teaching, and it has grown since then and acts as a research and teaching platform that supports not just our virtual environments module, but also a number of master student projects and a couple of research projects that have gone to various venues over the last couple of years. And it does this because it implements a lot of boilerplate stuff that is needed for experimentation, and so it's very useful even for experiments that are only tangentially networked, if that. So I'll start my talk by describing exactly what Ubiq is and how we expect users to interact with it before we get into how it works. Ubiq is a software project that implements the social and networking aspects of a distributed VR system. So it's written primarily for Unity and consists of Unity code, very comprehensive samples, and supporting materials like a Node.js server and documentation. The way we would imagine Ubiq being used is users download the project, they clone the example scene, they swap out the environment, they add their own objects and implement their own network behaviors, then build an executable to ship to their customers, participants, etc. So Ubiq is a library that's meant to work with other first and second party packages. So it's not an application like Altspace, it's not a layer framework like the RTK, It's not a platform like create a consumer platform like Roblox. Rather, it's a package concerned with networking. And it's actually a fairly low-level package at that. So users primarily interact with Ubiq through code. Ubiq is at its core a low-level message passing library. Now that might sound a bit odd, given our design goal of accessibility, but actually remaining low-level is quite necessary to support some of the niche use cases that we find in teaching and research. So if we imagine networking libraries on a spectrum similar to programming languages, at the very low level, you have the operating systems, networking APIs. In the middle, you might get some checkboxes or some decorators, but you don't really write much code. And at the other extreme, you have engines like Unreal, where the networking is built into the very structure of how you write games in that system. So it's just always there and you just turn it on. And in this respect, Ubiq is fairly low level. Users use Ubiq by creating their own networked objects, which is done in 4 steps. They define a message they want to send between components. They register their component on the network. They then send the message that they define, and then they pass the message, and sending and passing will then use that message or write their own logic to process that and make the component interact with the virtual environment to do something interesting. A lot of work has gone into Ubiq's API to make this process as simple and painless and as straightforward as possible. But ultimately, for both flexibility and pedagogical reasons, users do need to have a concept of the fact that there are multiple instances of their object on the network running in multiple copies of a scene graph. And these copies are exchanging messages in order to keep those copies, the copy of each peer or user, in sync, i.e. the core principle behind network VR and network games. The vast majority of Ubiq's high-level functionality is included as very comprehensive samples and subsystems, which we try to keep as decoupled as possible from each other and the core system. So if your experiment, say, didn't want to use voice chat, you could simply delete that whole subsystem and the behavior of the rest of the system remains unchanged. And the motivation is that we would fully expect that some experimenters want to modify or replace individual subsystems in addition to actually building applications. And so the samples are built in a way in which we expect users to use them as a starting point to build their own scenes. This is something that we see in teaching. Students will get a framework, they'll get a sample and they'll hack on it. So we fully lead into that. So they expect we give a small number of samples. We're a small team, we can only maintain so many samples, but those samples are very complete. They are built in a way in which we would encourage students to take them and hack on them to try out new things very quickly. So that's Ubiq in a nutshell. And for the bulk of my section, I'm going to go through the core concepts and principles that make it what it is in some greater detail. And we'll start with the programming model. So I'm sure most of the people watching this are familiar with Unity, but for completeness, in Unity, the way you code is you place your code on components that are attached to game objects. And the code in these components is invoked via callbacks from the main engine. Different components are responsible for different logical functions. So for example, in Unity, I have a torch. One component is responsible for rendering to the screen. Another interacts with the audio system to create sound effects. Another will drive the particle effect system, so on and so forth. Ubiq follows the same approach in that we expect users to write new components dedicated to the networking behavior of game objects. We provide an API so that users create what we call network components. These are basically Unity components, Unity model behaviors that have some network functionality using Ubiq. And the idea is that the component that they create will exchange messages with remote instances of that component, copies of that component running on other users' scene graphs. When messages are received from Ubiq, they're handed over to a method call, just like the other Unity systems, like update, like on trigger enter. And the idea is that by imitating Unity's existing models, Ubiq becomes immediately familiar to existing Unity users, which both increases efficiency and aids self-discovery. So I mentioned a couple of times components talk to other components. So the idea is that you write the code to send and receive messages inside one script to create a self-contained network behavior. So once a game object has a network component attached to it, it's network enabled, it will talk to all other instances of that object in the synchronized scene graphs. So you could have a game object with, say, 2 or 3 network components, and they send messages to the counterparts of that object running on the other processes. And you might have multiple copies of that game object. And again, the instances on each copy send messages to the corresponding instance on the copy of the other peer. So you don't send messages via classes. It's not like a message bus system. Just like Unity instances of Unity components, each have their own state. They communicate to the exact instance running on other processes. Ubiq derives a lot of information from the scene graph. So users place their network components on game objects. Obviously, that's a basic principle of how Unity operates. When the application starts, these components will associate themselves with a network scene. And this is a game object with a Ubiq component called network scene. The network scene is the most important component in Ubiq, and it's like the root of the scene graph as seen by the networking. So network scene, this is what actually creates the underlying connections to the server or to other peers. It dispatches outgoing messages and routes incoming messages to the correct component instance. So all applications must have a network scene to create the actual network connections. Now in Unity, we can't create new common subsystems like a new physics system, for example, which exists at the engine level. So network scene is implemented in a component that actually exists in the scene graph, in the Unity scene. And this game object, we take the opportunity by making it a game object to host other components that implement common Ubiq services. Having the network scene be an actual game object, however, does turn out to have its uses. Note in this screen grab here, the network component on the torch is not a child of the network scene. It's part of a game object that is a sibling. It exists at the same level. So when a component finds a network scene when it starts up, it uses a search procedure which returns the closest network scene to it. And closest by meaning like the distance metric, how many steps through the scene graph you have to take to get it, even if that entity is not in the same branch. And this allows us to do some quite neat things. For example, we can create different prefab variants of the network scene with different capabilities, say object spawn, experimental object spawning added, existing one stripped out, or similar with voice chat, and environments with different capabilities, so different sets of networked components. And we can then mix and match these in different ways in different Unity scenes, all without needing to maintain direct references in the editor. And we use this mechanism a lot in Ubiq across different systems. And it offers a number of opportunities that would be quite difficult to achieve in other systems. As an example, in the local loopback sample, we create multiple peers in one Unity scene. So communication-wise, these peers might as well be on separate PCs. They have their own state, their own network connection. They're seen from each other's point of view as if they are running far off. But we can debug and develop the code under one process and one debugger. In prior scalability tests, we created two peers that both affected the same environment, but one joined a command and control group on one server and another joined a test group running on an entirely different server. So we actually had two completely separate networks that actually communicated or interacted in some way via the memory space of a shared process. So this approach offers a lot of flexibility in how Unity scenes themselves operate and the kind of applications you can build. So I mentioned network scene, I mentioned the word peers. I'll just now address exactly what that is. So in Ubiq, we call the nodes or processes that host a network scene peers. Ubiq is inherently a peer-to-peer system. And this is because peer-to-peer communication is the most flexible architecture. You can implement other communication models on top of peer-to-peer, but not always vice versa. So logically, all peers in Ubiq communicate in a mesh or end-to-end manner. Every message sent by a peer is received by all other peers in the peer group, and the peer group is simply all the peers that are connected and will receive a message. So a peer group can be formed by having the network scene explicitly create connections, say TCP connections to other network scenes running on a process or any process on a different computer or the same computer. But most cases we would expect would use the rooms and server system. And I'll speak about this in a few slides, for the motivation for having this. But significantly at the messaging level, the important takeaway is that there's no information here about what other peers are connected. At the messaging on the networking level, the network is simply a black box in which messages go in and messages come out. And it's designed like this very deliberately. And this is for two reasons. One, it encourages user code to be written in a way that is agnostic to the network architecture and the number of peers, which is likely to make it more scalable and allows us, importantly, to change the architecture out from underneath an application, perhaps to do experiments to that effect, without actually changing the behavior of the application at all. And it also allows us to have different systems to manage the peer groups. So we have the server system that I already mentioned, but we could also do local network discovery if the local network supported that. Or for fixed installations or experiments, we could even hard code the initial connections depending on what processes we wanted connected and build a group that way. So how do objects communicate through this black box? Well, I said previously that objects talk to other objects, like component instances talk to other component instances. So in Ubiq, each object has a network ID. When a message is sent onto the network, sent onto this black box, it is sent to or with a particular ID, and it is received by every object, every network component with the same ID. That is, we implement application layer multicasting. And to see why we chose this particular model. Say, for example, I was a peer and I had an avatar. So I start up and I assign the ID 24 to my avatar. So the game object that is responsible for representing me in the world. So it has an appearance in it, it has a transform that is tracked live. And I add advertise this some way. By some mechanism, I advertise it to the peer group. As new peers join, they would see that I have an avatar and that I have the avatar consists of this prefab with this appearance configuration, and it has an ID of 24. So they then create a game object in their scene graph with that ID, with that same configuration. And all the while, I am transmitting updates, I pose updates with that ID. Now, due to application layer fan-out, a copy of that message is received by the counterparts of my avatar and every other peer in the peer group. But importantly, my avatar and the code that I write to implement my avatar doesn't have to know how many peers there are, if any at all. It only sends one message. And my avatar doesn't have to know about when peers come and go. Peers can come and go over time. They don't need to tell my avatar doesn't need to know about it. They'll simply receive the messages or not if they're not there and have the latest state, all without my code needing to be aware of the configuration of the group. So where do these IDs come from? Well, in the most common case, network components will send messages to copies of that component in the scene graph. When you register a network component, Ubiq gets a unique ID based on the location of a networked object relative to its network scene, which is again the networking equivalent of the scene root. You can actually see what these addresses are at runtime if you're interested, using the network ID gizmo object. You just attach that to a game object containing some network components. And this addressing scheme supports objects with duplicate names, multiple copies of the same networked component on a game object, multiple copies of the same game object at the same level in the graph. And so it'll even work across scenes and platforms, assuming the hierarchy under the network scene is the same. So in most cases, you just create one scene, you build an executable, and the scene, because there is just one, is just multiple copies of the same code running, that will always be the same. And so those instances will just line up. However, Ubiq does allow you to control the network ID explicitly, both the ID your component registers with or listens to, and the ID that your component sends to separately if needed as well. So, for example, in addition to components getting their addresses from their position in the scene graph, you could assign a fixed ID, a design time, and thereby create a service which receives messages from various other components in a client-server arrangement. Or two networked components on the same game object could communicate asymmetrically by addressing each other's network IDs. So you can build quite a variety of communication models using this approach. And Ubiq itself uses at least 4 different models across its services and samples. So one-to-one client-server, symmetric unicast, and asymmetric unicast, just off the top of my head. So, if you want to see other ways in which this API can be used, we just put up a blog post just a day or two ago with the latest to go along with the latest release of Ubiq, which goes into more detail, has a few different use cases that show how the API can be used to implement different models and what they might be used for. So I mentioned previously that we expect the majority of use cases to use a room system as server. The main purpose of the room system is to facilitate rendezvous over the public internet. So Ubiq is logically peer-to-peer, but there's just no way to do discovery over the public internet without some sort of shared secret. And in Ubiq's case, that shared secret is the server itself. When a Ubiq application starts up, at least our samples, the network scene makes a connection to the server. At the other end of this connection is a network component, the room server, and on the peer end, you have a network component room client. So the room client negotiates with the room server for membership of a particular room. And once the room negotiation is successful, messages between the new peer, you, and all the existing peers begin to be relayed, forming a peer group. So when the initial connection is made, communication is actually performed between these components using Ubiq's messaging system. In a way, you basically form, as soon as you make that connection, you form a peer group, and then by negotiating with one component, you can then expand the peer group once negotiation is successful through the relay functionality of the server. So when it starts, the server sandboxes that connection and then begins forward. So the server we provide supports multiple rooms and so peer groups. And this is simply so that we can support multiple experiments or teaching groups, but by only maintaining one server. The server itself is completely agnostic to what is running. It simply forwards messages. So you can have multiple copies of the same application with different peer groups, or different applications with different peer groups, and the server will host them all the same way. Each room in the room system is identified by a GUID. So clients have two ways to join rooms. They can use join codes, which are short, user-friendly codes generated by the server. These are intended to be used interactively, and when you see the start here basic sample scene, you'll see the first thing you'll see is a keyboard for typing these in. So the idea is that users share these out of band, so students would share them over Teams or WhatsApp or something, and they would insert those in Ubiq to join an existing room with the user interface. Alternatively, they can create or join rooms using room GUIDs directly, and this latter option allows us to do some fairly interesting things. So, for example, builds could be created to automatically join a predefined room. For example, build for a particular experiment without risking collisions when users have to come up with their own room names. In scalability tests, we used v5 GUIDs, i.e. GUIDs that are procedurally defined based on some other deterministic data, to create new rooms procedurally as users moved around a space that was divided into cells. So all users in a particular cell across all processes would end up in the same room without this ever having to be explicitly communicated either between users or from some sort of authority, simply by all computing the same ID based on where they were. The server itself is written in JavaScript for Node.js, and of course, like everything else, we provide it in full. The motivation for that technology stack is simply that it's very mature and it makes deploying a new server very easy. This is very important to us. It's important to us that it isn't just practical, but that it's not just possible, but practical and easy to create entirely local deployments of Ubiq, because there are many reasons why one would want to do that, data protection being an obvious example. The room client protocol isn't that complex, however, so other server implementations could be created if that were desirable. Really, the only thing that distinguishes the server from any other peer or network component is that it has this dynamically controlled forwarding and fan-out capability. One final thing, we also do make our development server, so the copy of the server running that we use to develop, publicly available. It is called Nexus, and it is in all the default examples. So if you just want to use that, you're very welcome to. So that concludes the core Ubiq discussion: messaging, architecture, addressing peer groups, and rendezvous. And so for the next part, what I'm going to do is just go through some of the subsystems that are included with Ubiq that enable social VR and how you might want to use them. So Ubiq includes an avatar system. The default avatars are 3-point tracked stylized avatars, the ones that you see in all materials. The avatar system really then mostly just instantiates prefabs, Unity prefabs. The tracking and everything else is done inside the network components that are attached to the avatar prefabs themselves. Consequently, it is just as straightforward to use, say, photorealistic avatars as any other. And we do have samples showing how to use the Microsoft Rocketbox avatars, for example. Avatars do have social features attached to them by default. This includes speech indicators, user configurable names. They can be customized, but of course, again, this has to be done in the avatar itself. So the customization is basically whatever you write. So our simple avatars support changing to a number of predefined textures, for example. We support voice chat. Voice chat is supported by WebRTC. So WebRTC is the technology stack that underlies real-time communication in modern browsers. So WebRTC was chosen mainly because it is really the only option for real-time communication in browsers, and so necessary to support our cross-platform ambitions. It's now an IETF standard that's based on a number of other technologies and protocols. So, for example, negotiation is performed using SIP. But the fact that it is a standard means that you can now write completely sort of clean room implementations of WebRTC, or at least white room implementations of WebRTC. So most software that uses WebRTC, such as the tools like the aggregators and multiplexers, will use the C++ library maintained by Chromium. That's the one that actually goes into Chrome. We use a C# implementation of WebRTC that is embedded into the Ubiq Unity package itself. So it's entirely managed implementation. And this allows us to target all the same platforms as Unity without having to maintain native binaries. It also allows us to use Unity's audio system to do things like spatialization and audio effects, whereas the Chromium library have to handle audio devices itself directly. So it's much more of a holistic experience building your application in Unity. All the typical systems work as you'd expect. There is a downside to this, though, and that it does result in slightly higher latency than an entirely native library would provide talking to the audio system directly. On the web, though, we do use the browser's implementation, basically by creating shims that call the JavaScript APIs. Again, this is by necessity. I'm going to go into too much detail, but if you're interested, one of the difficulties in browsers is that browsers don't allow you to create your own network connections. You need to use HTTP requests. You can use WebSockets. WebRTC will allow you to send UDP data, but only via channels once you've actually used WebRTC to create the connection. There are some considerations to do with browsers. So on the experiment and development side, back into Unity, or back into the desktop, Ubiq has a complete system for logging user events intended to support experiments. So users, when I say user now, I'm talking about the experimenter who writes the code. So designers raise events like they would other systems, for example, just calling debug.log. Ubiq will forward and relay these events from all peers to one machine for later collection and analysis. So log events are serialized as JSON with the intent that it is easy to ingest them afterwards in another tool like MATLAB or a Python pandas environment. As you can imagine, logging could introduce significant overheads. We do structure the code so that only when logs are actually written do they invoke serialization or any other such handling, and they don't generate garbage in the managed environment ever. And the idea is that it should be fine, again, ease of use priority, it should be fine to leave debugging calls in the code and just disable the level when you're not using them. Ubiq includes a component to spawn objects at runtime, for example, and to scope these to different levels as well. So, for example, objects can be linked to a user or room and destroyed when these entities go out of scope. This is implemented quite simply via a catalog, which is an asset that is maintained in the Unity editor by the user or developer. So on the subject of scenes, this is an interesting one. So in Ubiq, a network scene and a Unity scene are conceptually very different. So the network scene assists between Unity scene loads and maintains its state, maintains anything that's created under it, maintains the network connections, importantly. And the expectation is that Unity scenes may be added additively, as this is the process that Unity are trying to push now, or completely replaced, all the while the peer is a member of a single peer group. For example, you could imagine series of groups of peers wanting to navigate through different environments together as one use case. And this we use to great effect. We'll bring this example up another time, by a team of students who created a 2-scale maze challenge where some teammates became tied and some went inside a maze, and they used 2 different scenes to do that and allow them to interact as if they were in one. So Ubiq also has a component to allow synchronized changing of the underlying Unity scene. The current implementation of this is that Ubiq uses the don't destroy and load functionality, but we're constantly re-evaluating this because Unity is trying to move people away from this. I think they consider it kind of a hack that they regret introducing. So we will find a more robust mechanism in the future. So with that, those are the kind of the core systems that we provide in Ubiq for social VR. You can see all of these work together in the primary sample scenes, the start here local root back in the sample folder. And these are samples that are themselves a fully functioning social VR application. You just hit press play, you can create rooms, you can get people to join them, you can chat, you can spawn objects, you can interact just in those samples. And so to end this session, I'm going to do just a couple of things. I'm going to talk about a few general things that are interesting to note, not necessarily in Ubiq, but things that are important to network VR that we are thinking about, so that we have considered them. And then I'll do a little showcase of things that have been created in Ubiq before we take a break, and then hopefully go on to something a little more interactive. So one of the things I want to address is security. I'm sure this is a pretty important topic to many people. Ubiq operates in a high trust environment. So what I mean by that is we assume everything in Ubiq is trusted. So the other peers you're talking to are trustworthy. The connections between them are secure, and that the code running on them is benevolent. We do error checking, but this is not to provide security, but it's mainly to prevent coding mistakes by our users from taking out a process and limiting the effects should this happen. So, and you can see that this is the case by looking at where the error checking code is placed. Right? The vast majority of error checking occurs in the server, where the impact would be biggest if it were to go down due to malformed data. We have taken this approach deliberately for a number of reasons. One is that security is hard. We're not a cybersecurity group, and to write secure software is basically a whole project in and of itself. And the second is that many users don't need the overhead of a secure system. And this overhead, I'm not just talking about overhead in terms of compute resources, i.e. encrypting and decrypting stuff, but in understandability and deployment complexity. So I'll give an example in the form of one place where we do have to address this directly. And the example of WebSockets. So modern browsers won't make WebSocket connections to unsigned servers, which means that anyone who wants to run their own server, their own copy of own version of Nexus, needs to generate a certificate, and not just any certificate, but a certificate that is in some way related to a root certificate authority that the browser knows about. So right now, our server doesn't create a secure WebSocket server, and we use a proxy for browsers that want to connect to Nexus. Though we will get this functionality into the server as an option. Obviously, though, whether it's setting up a proxy or whether it's configuring a certificate for a server, if you want to do this as a researcher, you need to know enough about how these systems work in order to pull this off. And this is one of a small number but significant, consequentially, examples just of the environment and the technology stacks that we are working with, introducing constraints in how we can build Ubiq and what we can offer with it. One of the other things I expect we might get a few questions about is data persistence. Things in a social VR system that you can imagine should be stored semi-permanently, such as user details, names, avatar skins, that kind of thing. Spawned object data, locations and other properties, room metadata perhaps, that sort of thing. So I mentioned spawning before, and I said that Ubiq currently can scope object data to the room level. So stuff will persist as long as the room does. Rooms are destroyed when the last member leaves. So the most permanent data in Ubiq currently has the lifetime of a room. That's because if we store anything longer than this, we have to start making decisions about, do we leave it in memory? Does it go to disk? What happens when the server process restarts? Do we have limits on what users can upload? How long do we store the data, etc., etc.? Basically, you start reinventing databases, which is not something that we want to do. So our plan at the moment is to introduce a persistent API by basically introducing a Ubiquified wrapper around an off-the-shelf database or service, and to try and make an API that is very complementary to how existing stuff works, or perhaps even used by the existing services, but that actually behind the scenes is almost entirely outsourced to something that is easy to set up. So that's as far as we've got with that so far, but just to communicate our thoughts on it at the moment, we'd love to hear any more thoughts if you have any, or particular use cases you're interested in, but we are thinking about it. Ubiq, as I said at the start, Ubiq is a Unity package concerned with the social and networking aspects of a distributed VR system. And we want to keep it to that. Our samples, like the start here and the minimal examples, are meant to show how various networking subsystems interact to create a complete social VR platform. And we provide boilerplate code for common distributed experimental features like logging. Part of making these samples work, though, is having a complete stack that supports everything from initial connection creation to input processing. And so we have added some convenience features to make this happen while trying to keep the example code as clean as possible. So as an example, our player controller, it has components to allow it to process both desktop and VR controller input. And you can use the exact same prefab in your application without any configuration changes. You just press play and it'll drive a scene on both platforms. We also have a very thin action-based XR interaction framework, iGrassable and iUsable in the samples. But these are really only meant to do the bare minimum to support the samples, however. That they aren't meant to be replacements for a proper framework like VRTK. So they're safe to use, but they're not intended to support all use cases like our primary code base, which is concerned with networking and distributed VR. And in the very near future, we will be transitioning to use Unity's XR interaction toolkit, which we hope will reduce the dependency on just small sample code and make it even easier to integrate with other Unity packages. And the final thing I want to highlight is our experimental support for WebXR. So we support WebXR through cross-compilation in Unity, i.e. Unity builds to WebXR. And this allows Ubiq to work both in the browser in an XR and a non-XR based context. So we can build browser content either by directly writing JavaScript, like completely outside Unity, you just talk to Ubiq using our standard, or you can build an environment in Unity and then build it to the browser. With Ubiq, a user using a desktop executable could talk to an experimenter running in the Unity editor, could talk to someone in a web browser, could talk to research. By as many possible instructions could simply be as simple as follow it. So that's Ubiq, and I will end the first part of this tutorial by giving the final word to our users and to show off some of the things that have been created over the years. So just before I continue, I'm getting messages that say my internet connection is unstable. Can everyone still hear me? Ben, can you pop in the chat if everything's okay? Okay, thank you. All right, then let me okay, maybe we could re-record that during the break so you can cut it in. Okay, a couple of seconds pause for editing, and let me just finish off then by going through a few projects before we can go to the break. So the first example is 2-scale maze. And this was from the first cohort to do our network first coursework, and this is their video, give full credit. In 2-scale maze, groups split into two, and one half of the group sees the world in miniature and one half sees it in macro. And these participants can see each other. So the idea is that those outside the maze can manipulate the maze by moving tiles, but they can't see through all the tiles. So you have the miniature people will go into the maze and use voice chat to communicate to those outside the maze, so they work together to basically put the maze in a configuration which allows it to be navigated. Now, what's tricky about this problem is that in VR, you can't just make the camera smaller. So things like lighting, physics, or UI, these are key to a real world scale. So the way around this is these students actually created 2 scenes with basically almost it was identical content, but at different scales. So when you are in the maze and you see a giant avatar, that avatar is 100 meters tall in the virtual space. And when you see a miniature avatar, you're seeing something that is miniature. And now having 2 completely different objects, what would be seen by the engine as different objects communicate, would be quite tricky in a higher level or closed platform. But in Ubiq's messaging approach makes this actually completely trivial from a networking standpoint. Another project from this cohort is Transballer. This one isn't. Okay. Another Transballer is another project from that cohort. This is a cut of their video again. This is a fantastic contraption-like physics puzzle game where users need to work together to build Rube Goldberg-like apparatuses to get a set of balls from a spawn point into a hopper on the other side of a room, overcoming obstacles. There are various rooms with lots of obstacles and various things users can build, such as pipes, but also cannons, reflectors, carts, that sort of thing. So all the balls and the puzzle pieces were physically simulated, and these students actually implemented their own network physics based on the ownership model, whereby whoever spawned an item ran the physics for that. So you actually share the physics simulation between different users. Blockism is one from the year's cohort just gone. In this game, users need to work together to assemble items on a virtual assembly line. However, the trick is users are assigned one particular role where they're only allowed to interact with items that match their avatar color. So they have to work together, interacting only with the parts they're allowed to build up the object. And this limit is technically enforced. So a color of one user physically can't interact with a part of another. And the roles are auto-assigned as users join based on the number of players. So really cool project here, which needed tight control around room membership, identity, and interaction and mechanisms. Another from this year is co-rails. In this game, users have to build a railway track in front of a moving train by harvesting materials from the environment. Users need to use the correct tool to harvest the correct material. And if they drop the tool, it jumps back to the train. So they need to work together to harvest the right amount in the right proportions quickly enough, or the train will reach the end of the track and derail. And the goal is to get the train all the way to the other end of the map. This map is procedurally generated each time randomly, which is itself pretty impressive in the quality and balance of the environments their code comes up with, especially for how little time they had. This project generally had a lot of nice touches, such as the buttons, actual water balloons, which are physically simulated. You can hand over the balloon to someone else to actually start the game, which is very cool. This game's logic, as you can imagine, is quite complex to synchronize. There's lots of moving parts, and the collaboration itself is mainly enforced from the game's balance. Either it's hard for one person to keep up with the amount of materials that you need to harvest to keep the train going. And the last entry in our showcase is from a collaboration between a couple of members of our group, Nels Newman and Ben, who will give the second half of this, and the Science Project in Cyprus. This is an asymmetric outdoor mixed reality demo using Oculus Quest and the HoloLens 2. So the AR user is seeing both the real world and an overlay of a virtual world created using a capture of Nicosia, and they're aligned using QR codes placed throughout the environment. Whereas the VR user sees a recreation of this digital recreation of the real world with the AR participants located accurately inside it so that they can interact. So both interact in the same space and manipulate it together, for example, by planting trees in the middle of the road in the cover of night. So the model itself is provided by Nicosia, which is another project of Science, and Ubiq is used for all the networking and collaboration. And this is also, I should say, far from Nels' first mixed reality, or should I say cross reality project. So if you're interested in seeing more, do let us know. I'm sure I'd love to get in touch. So that's it for the first part of this tutorial. Thank you for sticking with us this far. We'll remain here in the chat and online during the break if anyone would like to ask questions or discuss anything. But otherwise, thanks for your attention, and we will see you after the break for our hands-on session.
Okay, hi everyone. I'll give our tutorial section of the talk today. This will be a cut down version of a tutorial that we have available as part of our documentation. So you can see a link for that in the chat. that tutorial will go step by step, take you straight from having no Unity installation tool to having this code running on the server and being able to connect and having all your objects work and everything. What we'll do today is a much kind of reduced version of that, just because it's not so interesting to watch projects sort of compile and load and all that kind of thing. So I'll still take you step by step through what you need to have installed and how to install it. So I'll share my screen now, and please let me know if this is if there are any issues with the stream itself. Okay, so what we have here is a Unity 2020.3 project, which we've started up fresh for this purpose. All we've done to get to this point is we have imported the Ubiq package, which you can find on our releases page on GitHub. And we've extracted that package out into our packages folder here. So this is what your packages folder should look like when Ubiq is imported. So inside you have kind of a standard Unity package, which is the form that we put Ubiq into for releases. So when you put this into the project, you click back into the project and it will load in. We also have this samples folder here. The samples folder comes from going to Window and then Package Manager in the Unity editor, and then selecting Ubiq here, clicking this drop down, and importing the Ubiq samples. So this is kind of all the samples that Sebastian was talking about. It includes kind of a sort of fully functional social interaction area where you can connect to other people and change room dynamically and change your avatar and you know, speak to people, all the functionality that you would expect of a social VR application. And then it also contains a large number of kind of minimal examples where you can try and see sort of exactly how all these individual features, many of which Sebastian talked about, work with Ubiq. So what we will do though is we will start with the start scene, which is in the top folder here. So we have there's start here and start here local loopback. So we'll just do start here, and this is that scene. So what's included in the scene is this UI that you can kind of interact with to change room, and then a sort of very simple environment. So we've gone ahead, and the tutorial online will take you through the steps to do this. We've gone ahead and already added our 3D pen object. At the moment, this is not in any sense a 3D pen, because all we have is two cylinders. Let's go and take a closer look. Two cylinders placed together in order to kind of very, very roughly emulate what a pen looks like. And then we've added a rigid body to make it work with Unity's collisions. So when we press play to try this out, we now have this pen object floating in the air, but we can't interact with it. So that's kind of our first step, is to add some interaction. So what we'll do is add this pen1 script, and I'll show you what it does quickly before we go into the script itself. So now we can pick up the pen, we can move it around with our hand, and it moves in the world. So this is a very, very simple script which uses Unity's interaction, which uses Ubiq's interaction toolkit. So we provide an interaction toolkit with Ubiq. You don't need to use it. You should feel free to use whichever toolkit you prefer, so MRTK or Unity's XR interaction toolkit. It will work fine with Ubiq. The samples are written with our simple toolkit, but the samples are just for learning, and realistically you can use Ubiq to add networking to any other library. And we sort of designed our system that way so that you can easily attach to even other avatars or other kind of representations of hands and that kind of thing. It's quite easy to attach. So what's happening in this script? We have implemented the iGraspable interface, which is that interface that's part of Ubiq's XR interaction toolkit. And all we do is when somebody grasps us, we set the controller that grasped us, and then we follow that controller around during late update, which is this Unity function that gets called after the update step every frame. And that's enough to give us our kind of simple movement. So if we now build this project, we're going to build it into a window. And we can see that when we have these projects running side by side, then when we press play here, we can join a room with this UI. So this is a way to allow users to join rooms and change room they're in while during runtime. And with this approach, users are in control of their own room. There are other approaches, so you can have users auto join a room or automatically push a user into a room with code. So this is all stuff that that's kind of very much up to you as a developer. With this little UI, it gives that control to the users. So with this user here, we joined a room and we're given this nice friendly join code QXQ. And we can see we've got the little pen there. Now we have, hopefully you can also see this, a window of another version of this application running. And we can put in that join code. And now we have our two users connected. So the users can kind of see each other. They both have avatars that can interact in this environment. But what you'll notice, welcome Swift Elephant. What you'll notice is that when we move, when we do that grab action and move this pen around, it moves for the user who grabbed it, but it doesn't move for anyone else. And that's because we haven't yet set up networking for that object's position. So let's go and do that now. So what we'll do here is replace that pen1 script with pen2, which is the second version. And pen2 will basically function exactly like pen1. Let's take a look at that script again, but with networking. So this is us adding the kind of the very basic form of networking that allows an object to talk to other copies of itself on remote users and to synchronize its position across users. So there are a few things here that we should go into. First thing is this message format. So this is we're defining this message. It's the kind of message that we're going to send to other copies of ourselves, and it's the message that those other copies will receive, and so they'll know how to interpret it. This is a very important step. Sebastian showed you some code with this in it too, but here we're registering ourselves with the nearest network scene in the scene graph. So what this means is that we ask that network scene to find us a network ID, and it will do that based on our position in the scene graph, and then register us under that ID. So that means pass us messages that are destined for the object with that ID. So that leads us to this function here, process message, which is where those messages will arrive when they get given to us. So you can see process message is receiving this scene graph message. We interpret the message using that data format above, and then we just use that message to set our current transform. So that means that it allows us to sync that transform across the network. we write the message sending here in fixed updates so that we're not sending an absolutely huge number of messages. And it's, you know, functionally as you would expect, we're sending this message with our transform in it. So we send it in the form of a JSON message. It's not terribly efficient, but you know, for the purposes of the tutorial, it's a very sort of simple and quick way to get something running. You can always add optimization later and send it in a binary form instead. And Ubiq uses a buffer so that we don't generate garbage on these message sending, although of course generating a string for JSON generates garbage. So you can send it as bytes without generating any garbage on the sender or receiver end. And this is how we send position updates with our avatars, for example, to make them more efficient. Okay, there's only a few other things the script adds, and it's this concept of ownership. So we only send the network message if we are the owner. So we're just adding a simple Boolean variable, and we set ourselves as the owner if we grab the object on our local in our local environment, in our local application. And then we set ourselves as not the owner if we don't. So that just means we won't be sending messages all the time, and that users shouldn't conflict when they send messages. But obviously, there's a note here, note about ownership. It's not a core part of Ubiq. It's just a helpful pattern for writing these scripts sometimes. There are many other ways of organizing this kind of script too, and you might prefer those. It's not something we enforce at all. Okay, so now we have our second version of pen, and let's quickly test it. Okay, 08F is our room code. 8F. Right, so we've got our two users again, and maybe we'll be joined by another. And if we now go up and grab this pen, we can see that the pen is now synchronized, and that, let's get a better look at it, and that it moves with this user's hand in both applications. So the pen is now has this simple form of networking, and its position is now being synchronized. Okay, so what the pen is currently lacking is any form of pen functionality, so we can't currently draw with it. So that's the next thing to add. So there's quite a lot in this script. We will go through it, but it's not all Ubiq specific. This is some functionality to make the pen work as a pen in 3D space. Incidentally, because we're now going to go through quite a lot of code, the tutorial link that I posted in the chat does have all the code files that we're going through and all the different versions. So if you want to take a closer look at the code, do go and look at that as I kind of flick through it in this presentation. Okay, so right, so what do we add here? Let's not worry about the variables, but we do add this IUsable interface. So this is another portion of Ubiq's XR interaction toolkit. IUsable allows subjects to be used, and iGraspable allows them to be grasped. So grasp basically allows you to pick up and move things around, and it's accessed with the middle mouse button on a mouse, or with the kind of the grip buttons on a controller. So for example, the second trigger on the Quest, or the side buttons on an old valve wand, or the sort of grasp functionality on a index controller. That all links to the graspable interface, and then the main trigger typically activates the usable interface, or the left mouse button on a mouse. The sort of central idea here is you can use items without grasping them, or you can pick up an item and then use it as you move it around. So let's go down to these usable interface function calls. So all we do when the item gets used is we begin drawing, and when it's unused, so when the person stops clicking the left mouse button or stops pulling the main trigger, we end the drawing. So these details are sort of very, the details of these functions, they're sort of very implementation specific and not very Ubiq specific, but they are sort of interesting. So I'll quickly go into them. So the way we do this is we add a trail renderer, we dynamically add a trail renderer to the nib of the pen. And then we allow that trail renderer to follow the pen as it moves around. And we set these functions here to make that trail renderer look a bit more like a sort of a nice line in space, not huge. We also set the drawing material, which is which we define up here in the start function. So that's all this does. We find a nice looking shader for the drawing material and we assign that to a material. And then we also find the nib just from the relative transform to allow us to draw from a specific point on the pen. So the only other thing to look at is when we end the drawing, we take that trail renderer, we separate it out from the nib and we make it its own object. And then we stop it drawing anymore. So then we just have a drawing which floats in space. So let's take a quick look at it now. We'll grab the pen. It's a little close to my face. We'll grab the pen from here, and then I'll start using, and then we can draw some nice things in 3D space. So let's say okay, it looks a bit more like 12, but here's a nice, let's call it stylized rendering of ISMAR 2022. And you can see this kind of exists in 3D space now. We won't worry about testing it because we know it won't work to synchronize it across the network yet, because there's no synchronization code in there. So when we draw, it will only be drawing for the local user. So again, without testing it, let's go ahead and add that networking functionality. So let's take a look at pen 4 with networking here. So this is actually, adding networking to this is quite simple. All we have to do is slightly change our messaging format to add another field here to show whether the pen is currently drawing. And we set that, whether it's currently drawing, just whenever we send this message, we'll also say whether we have a current drawing that we are drawing. So it's quite a sort of simple approach without much changing of code. And then the other big change is in process message here, where now we receive that is drawing variable and we do something with it. We begin drawing if we if the message says we should be drawing and we're not currently drawing. And we stop drawing if the message says we shouldn't be drawing and we are currently drawing. So it's just a way of kind of bringing those back into synchronized form. These begin and end drawing functions are unchanged. We're really just telling the remote copy just to do the exact same thing that it would do if somebody had used it. So let's test it out. Okay, so again, we have 2 copies of the same application running. I've joined a room in this version of the Unity editor, and I'll turn around just so we get a good look at Okay. Oh, was that a room code? Okay, JT4. Okay, cool. We once again have 2 users in the same room. And now I'll go grab this, this pen, and we'll draw. Cool. Okay, so now you can see that we now have this object just drawn, and it's in both scenes. So both users are now able to draw and to see those drawings synchronized. So if we take the pen over here and we draw just a scribble, a much less artistic thing, which we can kind of wander through and see that it has depth and so on. And then in this user, he gets the scribble too. There are definitely limitations with this approach that we've done here for this tutorial, and obviously networking is about defining exactly what you need, and usually not doing more than that, because the edge cases get incredibly complicated and add sort of computation weight and networking weight. But what we do here is we tell remote copies to draw, and so if those remote copies don't currently exist, so for example, say that somebody joins the room later, then those remote copies won't have this drawing information because they didn't exist at the time to do the drawing. So there are ways that we can get around this, the ways that we can make those drawings persistent. Persistency is a big word for us in Ubiq at the moment, but we can make those drawings persistent by storing them with the peer or room property dictionaries, which are lists of properties that get downloaded along with a peer whenever a new peer connects, or that exist along with the room and get downloaded along with the room. So by saving them with the room or with peer, then any new person joining could look up that peer, find their drawings and creations, and load them at runtime. And that in that way, they would be persistent to new users joining. I think a lot of the time you might not need that. You might be able to run an application just with the users that are already inside it. But if you do need it, it's there. And I think maybe an interesting sort of further exercise to do as part of this tutorial, if you're interested. If you do attempt it, yeah, please do let us know. It'd be interesting to see an implementation of that. Obviously, many other things you could add. You could add colors and so on if that was sort of appealing, and work out how to network it just to extend the tutorial a bit. But yes, hopefully this has been informative. If there are any, this is all we have to talk about today, but if there are any questions about Ubiq in general, me and Sebastian are here to talk it through. And yeah, I think that's everything. Please do check us out on GitHub. I'll just post the link in the chats when I'm done. Otherwise, yes, any questions? Okay, if there are no questions, I'll say thank you very much indeed for having us, and I'll speak to you soon.
Yes, thank you everyone for watching. Do get in touch if you want to chat more about any thoughts or your own projects. I always look forward to hearing from our users.
Okay, bye-bye.
Bye.